Hi, this is Ali and welcome to my channel. In the last video, we have learned how HTTP requests work and use Netcat to do such a request. We have also talked about how the internet works at a high level. This time, we will be on the other end of the connection. The browser will start a connection to us and we, playing the role of the server, respond to their request. Let's first start our server by running Netcat in listen mode on port 3001. Then, I'll open my browser and navigate to localhost on the same port. As I do this, we'll immediately see the first request arriving at our server. The browser sent us a GET request to root path using HTTP 1.1, followed by the headers. By definition, a GET request won't have a body. User agent header is telling us about the browser. We could use this for analytics purposes, for example. And it will accept a text HTML or a hypertext document, which we are familiar from the last time. Connection keep alive is also important, but we will come back to this later. Let's start from a simple one. I'll redirect this page to another. Let's respond with a permanent redirect with a status 301 using the location header without a body. We can redirect to any resource we want using the value of this header. As soon as I respond with this, the browser closes the connection to make a new request with the new path. Since we weren't listening for another connection, the browser displays a connection refused error. Let's try again once more. Start listening and navigate to the root path. We receive a very similar request. This time though, the browser asks for a different path, /index.html, even though that's not what we wanted. Because we have responded with a permanent redirect previously, the browser now remembers this and immediately asks for index.html. Now start the fun part. Let's render an actual page and start with a success status of HTTP 200. I'll open an HTML tag. As soon as I do that, the browser does something and initiates a fresh page for us. Remember from the last time that we can stream data on the connection. It is dependent on the network conditions, but in this case the network runs instantly, so our pace of writing to the connection is the determining factor. The actual server can do the same. It doesn't have to send the data all at once. Even if it does, there is no guarantee it will be transmitted as fast as the server can push the data. Remember, it is unreliable by default, and to optimize for this, browsers can show partial content to the user to improve responsiveness. It doesn't care if the delay is caused by the network or we are being lazy to respond. When we stream the head tag, now the browser is certain that we will have an HTML document and starts building the document object model, which we can see in the Elements tab. Note that we haven't closed the HTML yet, but the DOM representation assumes that it will be closed as we are already inside of that tag with our response. Let's now add a title to our document, saying Hello Browser. It's now visible in our page's title as well, and we have a corresponding DOM entry. Let's be a good citizen for now and close the head tag. We'll start printing some content inside of the document body in a div tag which stands for a division. We have a web page rendered. Let's add another div now. Oh, I did a mistake. Forgot to close the previous div. The browser now thinks we are inside of that initial div. Let's now see what happens if we don't close them. I'll just close the body and the HTML. It really doesn't matter for the browser because there is no way for the document to change the structure up to this point, and it just recovers naturally. This is not always like this though. In fact, there are very specific rules defining how each and every tag will behave when they are not paired properly. If you're interested, you can find additional links in the description. Even though we have closed the HTML tag and finalized the document, the browser is still waiting for this request to finish. This request that renders the web page is called the initial document request. There is no way I can finish this request now without killing the connection. That's because we did another mistake. Even according to HTTP 1.0, this wasn't a valid response. We simply didn't tell when we will stop. The browser still tried its best to show everything we threw at it, even though we have provided an HTTP 1.0 response. Now, let's do this once more. The proper way this time and using HTTP 1.1. Start at the server. We have received our request, our status line. Let's now tell for how long we will be writing to the connection using the content length header in bytes. Let's also send a content type header so that what we are sending is 100% clear for the browser. As the last header, we ask the client to close the connection after this response this time. Even though the client asked for keeping the connection alive, we rejected this as the server. Then I'll just paste the actual response body this time, which is exactly 105 characters long. As soon as I send the last character, the browser will automatically close the connection. The reason why the browser wants to keep the connection alive is to reuse the existing connection. A TCP connection has an initial handshake which takes a few round trips between the client and the server, and we can use the same connection for multiple requests. If we don't ask to close the connection, we can receive a new request on the same connection. Now, the browser is asking for the page's default icon. We simply don't have it. Let's respond with a 404 not found and close the persistent connection. In this video, I tried to explain how the initial document request works and how it is possible to stream it from the server. Understanding this basic working principle of web is essential, and I observed that even some experienced developers don't really understand it. If you enjoyed this one, go ahead, hit like, and don't forget to subscribe and click that bell because I'll continue to cover related topics. Until then, see you next time.